Hey, last day, which we're going to talk about indeterminate form and L'Hopital's. It's kind of weird that he just fit in here for L'Hopital, but it's kind of nice because you're going to like this trick. So we're going to talk about when we can use L'Hopital, why we can't say this, and let's get going. So indeterminate form, we've talked about before. The biggest indeterminate forms and the only two that AP will do are these guys with the combination of any plus or minus for the infinities. So these are indeterminate forms. And we knew that these always said for us to do more work. Okay. And all of the rest are also indeterminate forms, but those are the ones that we're going to be dealing with. It's kind of nice if you want to look for these. These are actually determinate forms. Fun to think through logically. Go ahead. And back in Unit 1, when we had an indeterminate form like 0 over 0 or infinity, we knew we had to do more work like factor, rationalize, common denominator, all of those fun things. But now we're going to learn another way. Think about if we got to here. Well, I cannot factor. I could try to split this up with a heartbreaker, but then that gives me infinity. And it's kind of like, there are no algebraic manipulations. What can I do? We need a new technique. That new technique is called L'Hopital. Go ahead and say it, folks. L'Hopital. So L'Hopital says that when we are taking a limit, so these are only with limits, first off, okay? So if we are taking a limit and we get an indeterminate form, then, ready for this? This is what L'Hopital says. That you can take the limit with the exact same c of the derivative of the f over the derivative of the g. So there's no product rule here. Not product. Oh my gosh. You guys yelling at me and saying, Miss Summer, that's not a product. No quotient rule here. Okay? So this is just a different rule altogether with limits. So when we are taking derivatives, we absolutely have to do quotient rules, okay? Low D high minus high D low, all over low low. But when we get an indeterminate form and you need to show this, then you can use L'Hopital. So don't just jump into L'Hopital, okay? You actually need to show that this is an indeterminate form. Okay. Just different mistakes. Lots of people would say, oh, I get this and I try to use L'Hopital automatically, but that would give you a different answer. L'Hopital only works, excuse me, only works if you yield an indeterminate form. So this limit would be 0 over 1, and that answer is 0. If I tried to do L'Hopital, derivative, plug in 0, I get the wrong answer. Okay, so make sure that you are using it appropriately, only when you get an indeterminate form. So let's look at this guy. This is how I want you to show me. When I plug in a 0, I get 1 minus 1, which is 0. When I plug in a 0, I get 0. 0 over 0 is an indeterminate form. So I am going to rewrite the limit as I go to 0 of the derivative of this guy over the derivative of this guy. And now I can plug in 0. And get my answer. Do not ever say this. No. You can never equal an indeterminate form. Like, there's no equaling about it. That is not true. Make sure that you should clearly show me that the top goes to 0 and the bottom goes to 0. There you have shown me indeterminate form. Then you have applied L'Hopital. Okay, let's try the next one. Sine of 0, 0. 4 times 0, 0. Indeterminate form, I get to apply L'Hopital. Cosine of 0 is now 1 over 4. Okay, let's look at this guy. E to the infinity is infinity. Infinity squared is infinity. I can clearly see that this is an indeterminate form now. So I'm going to use L'Hopital. Derivative on top, derivative on bottom. This goes to infinity. This goes to infinity. L'Hopital. Derivative on top, derivative on bottom. This goes to infinity. This is still 2. Infinity divided by 2 is infinity. I guess we can never really equal infinity either. So we also could have just looked and saw that this is bigger on top and gotten infinity. I will accept completely either way. Here we could see ln x, remember the ln graph, goes to infinity slowly, it's a creeper, and x also goes to infinity, so I could use L'Hopital. Derivative of the top, derivative of the bottom. Now I'm just going to rewrite this. And that goes to 0. Or I could have from the beginning saw bigger on bottom and just said 0. Either way is completely fine. All right, let's check this one out. Plug in 0. Now I cannot do bigger on top, bigger on bottom because I'm not going to the infinities. So when I plug in 0, that would be 1 cosine of 0 is 1 minus 0, which is 0. And the bottom is 0. So I see I need to use L'Hopital. Take the derivative and take the derivative. 0 now is 1 plus 0 minus 2. 0 now is negative 2. Oops, I think I did that one wrong on my notes. Well, we'll fix it now, won't we? Okay, so this would be negative 1 over negative 2, which is a positive 1/2. And that is wrong on my note key. I need to go fix that. Before I forgot to derive cosine to be sine. Okay. C. All right, next one. Ooh, these are. Here is an AP one. And let's look at this guy. So I go to infinity. Ln's going to go to infinity. Ln's going to go to infinity. So I'm going to L'Hopital. They're kind of growing with both ln's, so this one's harder to see. So derivative of the inside over the inside, derivative of the inside over the inside. And I'm just going to rewrite that by multiplying by the reciprocal. And now I kind of look at the leading terms. And now I see that they are both growing by an x squared, so I can take the coefficients. Simplify to 1/2. Okay, next one. As I approach 2. As I approach 2, f of x goes to 0. As I approach 2, 2 minus 2 is 0, squared is 0. So I get to L'Hopital. As I approach 2, f prime of x goes to 0, and down below I still have 0. So I get to apply L'Hopital again. Now, as I approach 2, f double prime is 5 n over 2. Okay, next one. Here, a particle moves along the y-axis so that this is the position. Show that the velocity of the particle is given by this guy. Okay, so y of t, I'm going to rewrite this a little bit. It's t squared times tan of t to the negative 1. So here I can see that this is going to be a product rule. First, times the derivative of the second, derivative of the outside, leave the inside alone, times the derivative of the inside. Plus the second times the derivative of the first. Cleaning that up, I see that those cancel to negative 1. And here, this is what we had, just reversed order. Okay, B says at time 4 over pi is the particle moving towards the origin or away from the origin. Give a reason for your answer. So on B, we need to know both y of 4 over pi and y prime of 4 over pi. So we need to know both of those. So plug that into your original. So 1 over 4 over pi would be the same as pi over 4, which is very nice. So that's going to equal 16 over pi squared times tan is 1. That is greater than 0. So now we just did the derivative, so now we're going to go plug it in. I'm just going to use the one that they gave us. And I would do that in case you ever made a mistake or something. Okay, so now this is 8 over pi times 1 minus secant of pi over 4. So secant is 1 over cosine of pi over 4, and then we want to square it. So 1 over radical 2 over 2, which would be 2 over radical 2, squared would be 2. So 8 over pi minus 2. Well, pi is less than 4, so we know that this is bigger. It has to be greater than 0. So this is still bigger than 2. Okay? So since both of these are our y is positive, moving in the positive direction, then we are moving away from the origin. And C, the velocity of the particle can be written as what they just showed right here. Find the limit as we as we go to infinity. So the limit as t goes to infinity, I'm going to rewrite that one too. Well, no, I think I'll leave it. Okay, so I'm going to think of this though as two separate problems. Kind of do the sky. Remember, since it's a minus, I can do it, and the sky. That's what I'm going to do. Okay, so if I plug in infinity, that would be 0. Tan of 0, sine of 0 over cosine of 0, 0 times 2 is 0. This guy also goes to 0. So I know on this part I need to do L'Hopital. So I have to take the derivative of this one. So I'm going to take the derivative of the outside, leave the inside alone, times the derivative of the inside. So 2. And then the derivative of this one. When I do that, these guys now cancel. And as I go to infinity, I know that secant is 1 over cosine of 1 over t. And we want that squared and times 2. So infinity here would be 0. Cosine of 0 is 1, squared is 1, and then times the 2 would give me 2. And then over here, as I go to infinity, kind of the same thing. That'd be 1 over cosine of 0 squared is 1. So now I have 2 minus 1, which is 1. Okay, the last that I have in these notes is just kind of some extras if you want to look over it. I think that they're fun to learn. It's not that you have to, so if you want to look over those and look over my key and ask me questions, you can. Other than that, guess what? Made it through Unit 4!